Welcome back. We're continuing to look at graphing reciprocal functions. In our last video, we graphed the basic reciprocal function y is equal to 1 over x, and we found it had vertical and horizontal asymptotes that were guided by what values of x and y were not possible. We also looked at what happened at the extremes and found that we were approaching our horizontal asymptote at the extremes, and when we graphed our function, we found it approached our vertical asymptote as well. So that first key step of finding what values of x and y were not possible was really important. So we're going to look at this example. It's a little bit more complicated. Y is equal to 1 over x minus 2 plus 1. And we want to look at what are the domain and range. First off, what are the domain and range? So this is really looking at what values of x and y are not possible. We want to kind of be thinking through these pieces. We used this idea of getting x times y equal to 1 to figure out what our values could and could not be. When I look at my function y is equal to 1 over x minus 2 plus 1, we can't quite see that. So what I'm going to do is I'm going to get this into the form of two things being multiplied equal to 1. So the first thing I'm going to do is subtract 1 from each side. And that gives me y minus 1 is equal to 1 over x minus 2. So then I'm going to multiply both sides by x minus 2. And that's going to give me x minus 2 times y minus 1 is equal to 1. Okay, so now I'm looking at something in the same form as that. So I can rewrite this as x minus 2 times y minus 1 is equal to 1. What I said over here when we were looking at how to find what values of x and y are not possible, what we said was that 0 times any number is 0. So neither of these factors can be equal to 0. So x minus 2 cannot be equal to 0, and y minus 1 cannot be equal to 0. So that gives me a domain restriction of x cannot be equal to 2, and a range of y cannot be equal to 1. Another way of finding this domain restriction is by using my property that I can't divide by 0. Division by 0 is not okay. So if my denominator is equal to 0, I am violating the rules of math. So x minus 2 can't be equal to 0. And that gives me, again, that domain restriction that x cannot be equal to 2. Additionally, 1 over x minus 2 cannot be equal to 0. A number divided by another number cannot be equal to 0. A non-zero number divided by any number can't be equal to 0. So then I end up getting that y cannot be equal to 0 plus 1, because if this can't be equal to 0, I can't substitute 0 in, so this would be illegal. So I end up getting that y can't be equal to 1. So that's two different ways of looking at it. I kind of like the first way as a starting point, but then I like looking at this piece because it leaves me with this as my range restriction. So we want to keep that in mind, and we'll actually pull that up and talk about it in our next video when we standardize this out. Okay, so my domain restrictions will always become my vertical asymptote. So you're going to take that not equal to, turn it into an equals, and that is my vertical asymptote. So I have a vertical asymptote at x is equal to 2. My range restriction will become my horizontal asymptote at y is equal to 1. So I have my two asymptotes there. When we graph these functions, now that we know the general shape, I'm going to have a vertical and a horizontal asymptote, and I'm going to have kind of these curves from one asymptote to the other. Right now I'm expecting in the top right and the bottom left quadrants. Since this is the shape I'm expecting, I want 3 points on each side of my vertical asymptote. So I am going to draw kind of a squiggly line, and this is going to be x is equal to 2. I need 3 points over on the left side and 3 points over on the right side. I also want to find my x and y intercept. I'll start with my x-intercept. X-intercepts occur when x is equal to 0. So that's y is equal to 1 over 0 minus 2 plus 1. That's negative 1/2 plus 1. Or my y-intercept is at 0, 1/2. So that's right there. And I can put this into my table, 0, 1/2. My x-intercept happens when y is equal to 0. So that gives me 0 is equal to 1 over x minus 2 plus 1. Subtract 1 from each side. Negative 1 is equal to 1 over x minus 2. Multiply both sides by x minus 2. Negative 1 times x minus 2 is equal to 1. Negative x plus 2 is equal to 1. X is equal to 1. So this gives me the point 1, 0. So I have those 2 points. Now I see that I have a point that is getting pretty close to this asymptote. So I want to get a point where my graph is starting to approach this asymptote. So I'm actually going to plug in 1.5. So if I plug in 1.5, I'm going to get y is equal to 1 over 1.5 minus 2 plus 1. That is going to be 1 over negative 1/2 plus 1. This is going to be negative 2 plus 1, or negative 1. So 1.5, negative 1. My graph is kind of curving here to approach this asymptote from below. It's not going to cross, it's just going to approach, and that asymptote there. Let me graph this in a different color so we can kind of see it. We're approaching that asymptote there. Now I need 3 points on the other side. I was lucky enough that 2 points, my x and y intercepts, were both on this side. Now I need 3 points. So I think I'm going to go with 1 unit away, so that'll be 3. Then I'll go with 2 units away, but then I want to go with half a unit away, so that'll be 2.5. If I plug in x is equal to 4, y is equal to 1 over 4 minus 2 plus 1, that's 1/2 plus 1, or 1.5. So 4, 1.5 will be about there. If I plug in x is equal to 3, y is equal to 1 over 3 minus 2 plus 1, that's 1 plus 1, or 2. 3, 2. And if I plug in 2.5, so y is equal to 2.5, or y is equal to 1 over 2.5 minus 1, or minus 2 plus 1. This is y is equal to 1 over 1/2 plus 1, or 2 plus 1, which is 3. So I have 2.5, 3. My graph looks like this. I approach this asymptote from above, I approach this asymptote here. So just to make it a little bit more clear, my graph looks like that. So my domain and range, x cannot be equal to 2, x cannot be equal to 1. I have my x and y intercepts here. I can label them on my graph if I want, call them out 1, 0, 0, 1/2. I have 3 points on each side, and I connected so that it approaches the asymptote.